Hi, good afternoon. Thanks for coming to my talk. The title of my talk is The Fate of Climate Refugia in the GBR. But I made a note there that the paper that related to this talk is currently under embargo, so I'm not allowed to share the main results. But I hope I can say something that's of interest to you. So first, I would like to acknowledge the peoples who are the traditional custodians of the land and pay my respect to their elders, past, present, and emerging, and also extend respect to other Indigenous Australians who are present. So I'm from Western Australia, so I would like to also extend my respect to the Whadjuk Noongar people who are the traditional owners of the land. So the goal of this study is to use dynamical downscaling to evaluate the fate of climate refugia in the GBR. So today at lunchtime, somebody asked me what is dynamical downscaling. So I think I need to give a little bit of explanation. When you use dynamical downscaling, means you use a dynamic ocean model that resolves ocean dynamics to simulate future climate using climate model forcing for the model, so that you can have a physical simulations of the future climate. We did it for 2 decades, 2050s and 2080s. This is nested inside the OFAM3 downscaling model, which I will show quickly. So a note is this has been on the to-do list for a long time, and we finally completed it thanks to ARAP. And the experiment was challenging and took longer than expected, but that's what happens with modeling, I suppose. So some background information. CSIRO has funded a strategic dynamical downscaling project a few years back. Some of you might be familiar with it. So this uses the ocean forecasting Australia model called OFAM3, which has 10-kilometer resolution, and it's near global, and it's eddy resolving, and you can see on the animation, you can see the EAC eddies and the eddies shedding from the Lewin current. Because it's 10-kilometer resolution, the tides are not explicitly simulated, which is why we are very keen to use the GBR4 model, which explicitly simulates the influence of tides on the circulation. So this is under the high-emission scenario, RCP 8.5, and using the CIMIT5 model. We also have a historical run and a control run. This is just to show how well the OFAM3 model can resolve eddy features. This is the standard deviation of sea surface height, and on the bottom right is the OFAM3 model, and on the top left is the observed variability in sea level from the satellite altimeter data. So on the top right is the same model as OFAM, but at 1 degree resolution, at 100-kilometer resolution. And you can see it captures the variability, but not the strength of the variability. Some background information for this study is there have been a body of work under the NESP Tropical Water Quality Hub, looking specifically into oceanographic drivers of bleaching in the GBR. So this is part of the inspiration for this work. And on the right, you can see that's from Craig Steinberg's report, the simulation of upwelling and the intrusion along the shelf in the GBR. So the blue are the upwelling of cold water up to the surface, but the pink ones are upwelling along the seafloor. The cold water does not reach the surface. I listed some related studies to show that there have been lots of interest in looking at climate refugia, the annual severe bleaching events, and also modeling of connectivity in the future, and what's the impact of large-scale circulations on connectivity, and some references on the persistence of upwelling along the GBR shelf. So this one, on the most right-hand side, are from Susan Wilful's paper using the satellite 2-kilometer data to show that in February, the climatology in February, you can see persistent cooler temperatures along the shelf across the GBR. So on the top is the northern and the central GBR, and on the bottom is the southern GBR. So that you can see the deep, the cyan color stands out along the shelf. And in the middle is a figure from the paper by McWhorter et al. To show the climate refugia using a semi-dynamic downscaling method, the persistence of climate refugia. Basically, the blue dots in the southern GBR are the refugia that they identified. So in our study, we defined the thermal refugia. So they defined the thermal refugia as 20% of the lowest 20% of the degree heating weeks in their downscale results. In our study, we defined the refugia as the areas that are constantly cooler than the surrounding areas along the same latitude for more than 1 degree. So from the OFAM3 simulations, downscaling, here I'm showing you the difference between 20-year periods, end of the century and the beginning of the century. So on the top left is SST, and that goes up to 3 degrees. Remember, that's CMIP 5 projections. I think CMIP 6 gives you a higher value. And in the middle is the salinity, sea surface salinity. So the blue means it's freshening. On the right is mixed layer shallowing. Warming and freshening results in the shoaling of mixed layer depths, which this is consistent with McWhorter's recent paper to look at stratification effect on insulating the mesophotic reefs from coral bleaching. On the bottom, what we're showing is there are significant circulation changes in the future climate. But I won't go into too much detail. So here I just want to mention that the first sentence is from GPT-4, said the role of upwelling on mitigating bleaching remains an area of ongoing research and debate, which I find, yes, that's probably true. Mechanisms of upwelling, it can be wind-driven, it can be interaction between the topography and tidal currents and ocean currents, especially through dense reef matrix with narrow reef channels. Clotilde gave a nice talk with nice simulations of very high resolution modeling showing the tides going through the reef matrix. And so that's one of the main reasons for the cooling in the northern GBR and the southern GBR region along the shelf. We don't know how climate change may affect upwelling dynamics in the GBR region. So there are speculations, maybe the warming, under the warming, it might not be effective, or there might be changes in atmospheric circulation patterns and so on. But we have a better answer in our paper when it's coming out. Yeah, a bit of discussion. So dynamic downscaling is great because it gives you physically consistent results, but it's very expensive and time-consuming. And what we've done is hydrodynamic modeling, downscaling only, so we didn't consider biological factors. And how effective refugia will be is dependent on coral adaptation. So I'm very heartened to see all this work on trying to understand how corals will adapt in the future and how the thermal tolerance will change. And we indeed need a higher resolution simulations to resolve reef scale circulations. If you listen to Robert Mason's talk, you will appreciate how important the local features are in coral recruitment and settlement. I think that downscaling results, nevertheless, will be very valuable because they will give you a training data set for using statistical methods, including machine learning, which will be very fast and give you robust climate projections on the different scenarios using different models. And so my colleague, Ajita Syriac, has recently submitted a paper using a developed machine learning model similar to the one, the picture I showed here, based on deep learning to downscale SST extremes at the GBR. So I think a key message is everybody would agree climate change remains the biggest threat to coral bleaching, coral reefs globally. And this message resonates with me is there's no silver bullet, but every action counts. And, but we do need a better scientific understanding to assess the benefit of climate refugia as defined by different studies. We need to understand the effects of heat stress on coral reefs, adaptation potential, recovery rates. And we did, in our study, we did demonstrate there's significant changes in ocean circulation in the future. So there are implications for ecosystem connectivity and functions. And climate refugia is likely to be overwhelmed by rates of warming, but it can allow us time to adapt and for interventions to work, so it's important to protect it. This is just a quick acknowledgement for all the contributors to this study and to the CSIRO EMS team, to Ames, Barbara Robson and her student, and thanks REP and CSIRO for funding.
Time for one question.
Not so much a question, I just wanted to make the comment that this embargo might have limited Chaojiao a little bit, but it doesn't stop her from talking at afternoon tea about all the results.
Thank you.
Yeah, thank you for that.